Chapter 3, pair of linear equations in two variables. So we'll lightly jump on the first question. A pair of linear equations a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0 is said to be inconsistent. Inconsistent is something which is not consistent. There is no consistency. So for this, whenever we solve two equations, if we get a solution, if a solution exists, we say it is consistent, or else it is not consistent. So no solution, no consistency. So it's not consistent. In linear equations, when do we get this condition of no solution? Only when the lines are parallel to each other. So for this condition, a1 by a2 should be equals to b1 by b2. This is the condition. That's our solution. Second question. Graphically, the pair of equations represents two lines which are intersecting at one point, parallel intersecting at 2 points. So let us check these two equations first. We'll find the ratio of x coefficients 7 by 21 and the y coefficients are -1 by -3 and the constants are 5 by 10. This is 1 by 3, this equals to 1 by 3, this is 1 by 2. So these two are not equals to 1 by 2. So a1 by a2 equals to a2 by b2. Sorry, a1 by a2 equals to b1 by b2. So it's the first problem. Lines are parallel to each other. Next, third question. The pair of equations have. So again the same condition, 3 by -6 equals to -5 by 10 equals to 7 by 7. This is -1 by 2 equals to, this is again -1 by 2 equals to 1. These two are not equal. The first two ratios are equal. So these two lines are parallel here. If lines are parallel, there is no solution. Option C. You can definitely expect a question on these models basing on the ratios of the. Let's discuss this first. a1 by a2 equals to b1 by b2 equals to c1 by c2. So these are the three ratios we can get. In this, the first two are not equal, then we can say that the two lines are intersecting lines and we only get one solution here. Because we have a solution, we can say that it is consistent. The second possibility, if a1 by a2 equals to b1 by b2 and these two ratios are not equals to c1 by c2, we say that the lines are parallel. And if the lines are parallel, there is no solution. And if there is no solution, we say they are not consistent. The system of equations are inconsistent. And the third possibility is that if a1 by a2 equals to b1 by b2 equals to c1 by c2, we say that the lines are coinciding. The meaning of coinciding is that it's the same line. If you take a linear equation like 2x plus 3y equals to 5, if you multiply a constant k for this entire equation, or if you multiply some number, let's say instead of k, we'll multiply a number like 3, is 6x plus 9y equals to 15. So these two equations are one and same. These two lines are coinciding lines. So for these two lines, we have infinitely many points. But we do have solution, but we have infinite solutions. Since we have a solution, it is the consistent system of equations. So we'll go to fourth question. If a pair of linear equations is consistent, then the lines will be always coincident, parallel, always intersecting. Since it is consistent, solution exists, and the solution exists in two cases, intersecting or coincident. Next, move on to fifth question. The pair of equations x equals to 0 and x equals to 5. X equals to 0 is, this is the origin. X equals to k is a line which is parallel to y-axis. If x equals to 5, this is 5, and this will be my line. And x equals to 0 is at the origin, which is passing through this y-axis. In fact, y-axis is the line whose equation is x equals to 0. These two lines are parallel to each other, and these two lines have no solution at all. So option A. Next, sixth question. The pair of equations x equals to -4 and y equals to -5 graphically represent lines which are, so these two lines are x equals to -4. X equals to -4 is somewhere here, a straight line parallel to y-axis, and y equals to -5 will be lying somewhere here. They will intersect at a point whose coordinate is -4, -5. Option B. These two lines intersecting at -4, -5. Next, seventh question. For what value of k do the equations represent coincident lines? We know the condition that it is a1 by a2 equals to b1 by b2 equals to c1 by c2. This is our condition. Just substitute the values. 2 by 3 equals to -3 by k equals to 10 by 15. So here you must be very careful. In the question, you may try to change these values. You may give this equation as -3y plus 2x plus 10 equals to 0. You may give this equation in this form. So don't consider the ratios of -3 by 3 here. Take the coefficient of x, always x. Since the lines are coincident lines, you must always take these two equations and these two. Never take only these two, because they will fall under the category of parallel lines. You must always equate the first and the second ratios to the third ratio. So from here, the ratio -3 by k equals to 2 by 3, and the value of k will be -9 by 2. This is the value of k. Eighth question. If the lines given by 2x plus ky equals to 1 and 3x minus 5y equals to 7 are parallel, then the value of k is, these two lines are parallel now. In the sense, take a1 by a2 equals to b1 by b2. No need of checking the third ratio. These two ratios are enough. This is 2 by 3 equals to k by -5. So k should be equals to -10 by 3. Ninth question. One equation of a pair of dependent linear equations is 2x plus 5y equals to 3. The second equation will be so the equation is 2x plus 5y equals to 3. So for this equation we need to multiply a constant k. The first option, the constant was changed, which is 6, and the second option is completely different, and option C is minus 10x minus 25y plus 15 equals to 0. If you multiply minus 5 for this equation, it is minus 10x minus 25y equals to minus 15, which is minus 10x minus 25 plus 15 equals to 0. And option D represents the same equation actually. If you multiply minus here, it's plus. So these two are the possible answers. Next, if x equals to a, y equals to b is the solution of the equations, then the values of a and b are respectively. We should solve these two equations. So the first equation is 2x plus 2y equals to 10. I multiplied 2 for this equation, and the next equation is 2x minus 3y equals to 4. In this chapter, to solve these equations, linear equations, we have three methods. One is the substitution method, and the next is the multiplication method, cross multiplication method, and third is the elimination method. So we can follow anything. So subtracting these two equations, 5y equals to 6, y equals to 6 by 5. So this one is enough now. So this is the option D is the only one where y equals to 6 by 5. The graph of x equals to minus 2 is a line parallel to the. So x equals to minus 2. This is minus 2. The graph will be a straight line, a vertical line, just parallel to y-axis. The graph of y equals to 4x is a line. In linear equations, ax plus by plus c equals to 0. If my constant is 0, then the equation always passes through the origin. Here the given equation is y equals to 4x. Y equals to 4x always passes through the origin. So it's a straight line passing through the origin. Next, the graph of y equals to 5 is a line parallel to the. So y equals to 5. This is 5, y equals to 5. So it is a line parallel to the x-axis. Two equations in two variables taken together are called as. So the chapter name itself is the pair of linear equations in two variables. So whenever we take two equations, they are called as simultaneous equations. In this question it is, this is AM does not equals to BL. If AM does not equals to BL, then the system of equations as, so take the ratios A by L equals to B by M, and next is C by N. So the given condition is that, this is the given condition. From this we can write A by L is not equals to B by M, dividing both sides with BM. So L comes this side and M goes that side. A by L does not equals to B by M. So here for this, these two are not equal. So we have a unique solution because they're not parallel lines. Next is 16th question. If in the equation x plus 2y equals to 10, the value of y is 6, then the value of x will be. So pretty easy. X will be equals to 10 minus 2y, which is 10 minus 12, it is minus 2. The graph of the equation is a vertical line, a straight line, horizontal line. We never get a vertical line and a horizontal line. So for the vertical line, the general equation is x equals to k, and for the horizontal line it is y equals to k. If you plot a graph for this, you'll get a line like this. It is a straight line. The value of k for which equations has a non-zero solution. So it is having non-zero solution. This is 3x plus 5y equals to 0 and kx plus 10y equals to 0. If I take option 1, which is 6, if k is 6, I will be getting 6x plus 10y equals to 0. These two are coincident lines. So for coincident lines, we have infinitely many solutions. If k equals to 0, y equals to 0. If k equals to 2, you'll get 2x plus 10y. So for all the cases, you get the solutions as 0, 0, 0. Only for k equals to 6, the two lines are coinciding where you'll get infinitely many solutions. So the value of k is 6. 19th question. The value of k for which a system of equations has infinitely many solutions. Infinitely many solutions in the sense coincident lines. So just take for the ratios. 1 by k plus 1 equals to k plus 1 by 9 equals to 5 by 8k minus 1. As I said earlier, just try to equate first and the third or the second and the third, but don't try to equate first two equations. We must equate the first two ratios only for parallel lines, so don't do it for coincident lines. I want to equate these two. 8k minus 1 equals to 5k plus 5. So from this we will get 3k equals to 6, k equals to 2. Option A. 20th question. The value of k for which the equations has no solution. So when we say no solution, they are parallel lines. So 3k plus 1 by, take this as 2k plus 1 equals to 3 by k minus 2. The first two ratios are equal for parallel lines because a1 by a2 equals to b1 by b2. I think there's some printing mistake by getting the quadratic equations. Let us try to solve this. So 3k plus 1 into k minus 2 equals to 3 into 2k plus 1. This is 3k square minus 6k plus k minus 2 equals to 6k plus 3. So 3k square minus 6k minus 6k minus 12k minus 11k minus 5 equals to 0. So this is our quadratic equation. Let's try to substitute the values of k from the options. If I substitute 2, this is 2 square is 4 into 3 is 12 minus 22 minus 5, no. Not getting the solution for this. If k equals to minus 1, this is 3 plus 11 minus 5. If k equals to 3, this is 3 square is 9 into 3 is 27 minus 11 into 3 is 33 minus 5 equals to 0. So we skip this question, there's a mistake over here. We'll move on to the next question, 21. The pair of equations x equals to a and y equals to b graphically represents the lines which are. So these are the lines which represents the point a comma b. So these two lines will intersect at a comma b. Here we have the word problem. Asha has only 1 rupee coins and 2 rupee coins with her. If the total number of coins that she has is 50 and the amount of money with her is 75, then the number of 1 rupee and 2 rupee coins are respectively. We can solve this question in traditional method, but instead of that we can just substitute the options here. We'll just try and verify the options directly. If I have 35 1 rupee coins, that will be 35 rupees, plus if I have 15 2 rupee coins, that 15 is 30. Just a minute. Yeah. So 15 into 2 is 30, which gives you 65. So option A is not satisfying. This is 15 plus 70 is 85, no. And 35 plus, this is 40. 35 plus 40 is 75. We're getting the option just 35 plus 40, which is 75. And 25 and 25, right? So 25 plus 50, 75. We're getting two options. But given that the total number of coins that she has is 50, so 25 plus 25 is 50 coins here. This is 55. So option D is the correct answer. Third question. The father's age is 6 times his son's age. 4 years ends. The age of the father will be 4 times his son's age. The present ages of the son and the father are respectively. For the ages problem, I'll try to recommend a method to avoid confusion and making mistakes. So always divide the time into 3 parts, like the present, past and the future for all the problems. Whenever we get a problem based on the ages, first divide the time. The father's age is 6 times his son's age. Let us say we have the father and the son. If the present age of son is x, then the father's age is 6 times of his son, which is 6x. 4 years ends, the age of the father will be. The meaning of 4 years ends is from after 4 years, like we are going into the future. So after 4 years, the age of the son will be x plus 4. So just try to understand and think logically. If your current age is 20 years, let's say, after 4 years it will be 24. So similarly, if the current age of the sun is x years, after 4 years it will be x plus 4. So just add 4 for the present age. So do same thing here, just add 4. So these are our future ages. So after 4 years, the age of the father will be 4 times his son's age. So this expression 6x plus 4 will be 4 times of the son's age in the future. So this will be 6x plus 4 equals to 4x plus 16. So 2x equals to 12, x equals to 6. If x equals to 6, father's age will be 36. That's it. Next question, 24th question. The sum of the digits of a 2-digit number is 9. If 27 is added to it, the digits of the number get reversed. The number is. In the option, sum of all the digits are 9. So 2 plus 7 is 9, 7 plus 2, 4 plus 5, and 3 plus 6. But if 27 is added, to it, the digits of the number gets reversed. If I add 27 for 27, I'll be getting, for first option, I'll get 27 plus 24 as, this is 54. So this is 27 and this is 54, no. And for 72, if you add 27, we will get 99, no. So option C is 45 plus 27. This will give us 72, no. And the option D is 36 plus 27, which gives us 63. 63, we can get 63 by revising the digits, 36. If you swap these two digits, we get 63. So option D. Twenty-fifth, the pair of linear equations. So apply the conditions. 2 by 4 equals to 3 by 6 equals to 5 by 10. So all the ratios are 1 by 2. So they are the coincident lines, which is consistent. If you look at the options, there are 2 options: consistent, dependent, consistent. For coincident lines, we never get one solution. So we get infinitely many solutions. These infinitely many solutions depend upon the value of x. So they always depend upon the dependent variable. So in mathematics, always the dependent variable is x. So it is called as the dependent consistent. That's not required as of now. So 26th question is, the pair of equations this is x equals to minus 7, I guess. So if you try to plot a graph, y equals to 0 is x-axis, this is y equals to 0, and x equals to minus 7. X equals to minus 7 is here. They're meeting at one point, which is minus 7 comma 0. So we have only one solution. Twenty-seventh question. The pair of equations x equals to a and y equals to b graphically represents lines which are intersecting at a and b. This question just disappeared from here. We'll go to next. 29th. So pair of equations represents 4, 3. These two equations are called. So these two equations are called as pair of linear equations in two variables, or chapter heading. A pair of linear equations which has a unique solution x equals to 2 and y equals to minus 3 is. So directly substitute the values of 2, minus 3 in the options. For the first option, 2x plus y. So 2 minus 3 is minus 1. This is 2 into 2 is 4. 4 minus of minus 9. So option A is not satisfying. Option B is 2x plus 5y. 2 into 2 is 4. 4 minus 15 is minus 11. And the second equation is 4 into 2 is 8. 8 minus 30 is minus 22. B is getting satisfied. But also check the other options even. X equals to 2 is 2 into 2 is 4. 4 minus of minus 3, no. And this is 2 plus 12 minus 14 is satisfying. The second equation is 5 into 2 is 10. Minus 3 minus 13. So both B and D are getting satisfied. So just try to solve them. If I solve the D, x equals to 4y plus 14. So 5 into x is 4y plus 14 minus y minus 13 equals to 0. This is 20y plus 14 into 5 is 70 minus y minus 13 equals to 0. This is 19y plus 70 minus 13 is 57 equals to 0. So y equals to minus 3. So y equals to minus 3 in the sense x equals to 2. So option D is the correct answer. Now we're checking the option B now. I think the same question, the father's son. The answer is C. 34th. Solution of these two equations. So adding these two equations, you'll get 2x equals to 6, x equals to 3. If x equals to 3, y equals to 1. Option C. The difference between a two-digit number and the number obtained by interchanging the digits is 27. So the difference between a two-digit number and the number obtained by interchanging. So if xy is my number, we represent this number as, this is ones, this is tens unit. So y into 1 plus 10 into x. The difference between a two-digit number and the number obtained by interchanging the digits. If I interchange the digits, I'll get yx. This is represented as x plus 10y. And the difference of these two, so minus of x plus 10y is given as 27. We need to find the difference of two digits, that is x minus y equals to how much. So solving this equation, y plus 10x minus x minus 10y equals to 27. This is 10x minus x is 9x minus 9y equals to 27. Taking out 9 common, x minus y equals to 27 by 9 is 3. So the difference is 3. Thirty-sixth question. The equations represent the same straight line if. So here it's about the coincident lines. A by D equals to B by E equals to C by C. So this equals to 1. Now don't try to equate these two equations as I said earlier. First equate these two and then these two. If I equate so, B equals to E and A equals to D. So A equals to D and B equals to E. If I multiply these two, I'll get AB equals to ED, or if I divide these two, I will get B by A equals to E by D. I can write BD equals to A. So any of these is correct. So I don't have any BD equals to A, so option D is the correct answer. Next question. Using the following equations, find the value of P if P equals to 5x. I think this is x here. That should be x there. So adding these two equations, 2x equals to 15 and x equals to 15 by 2. So P will be 5 into 15 by 2. So that's how we can do. I think the question is wrong here. The printing was not there here. Just skip that anyhow. 39th question. Find the number of solutions of the following pair of linear equations. So find the number of solutions. Let us find the ratios. 1 by 2 equals to 2 by 4. And the other ratio is, here he gave this minus 8 on the left hand side. If you send that side, it's plus 8 by 16. So all the ratios are 1 by 2, 1 by 2, 1 by 2. So the lines are coincident where we have infinitely many solutions. So we have infinite solutions. Write whether the following pair of linear equations is consistent or not. X plus y equals to 14, x minus y equals to 4. So we have the unique solution. If you add these two, 2x equals to 16, x equals to 8. So it's a unique solution. So the system of equations are consistent. 41. Given the linear equation, write another linear equation in two variables such that the geometrical representation of the pair so formed is parallel lines. So for parallel lines, 3x plus 4y plus any constant is fine here. So in the place of k, we can put 5, 6, whatever you want. Next, 42nd. Find the value of k for which the given pair of linear equations has no common solution. I think this is k. So the ratios are 4 by 8, k by 12 and 5 by 10. The meaning of no common solution is something but no solution. So for this to happen, these two should be equal and this should not be equals to 5 by 10. The ratio of 5 by 10 is 1 by 2 and this is also 1 by 2. So 1 by 2 equals to k by 12, k equals to 6. Find the value of p for which the given pair of linear equations has infinitely many solutions. So equate the first ratio 4 by p, which is equals to minus 4 by 12. Equating these two, 4 by p equals to minus 1 by 3. So the value of p will be equals to minus 12. The larger of two supplementary angles exceeds the smaller by 20 degrees. Find the angles. So given x minus y equals to 20. So the sum of two supplementary angles is 180. Adding these to 2x equals to 200 and x equals to 100. If x equals to 100, y equals to 80. On solving the following pair of linear equations by substitution method, values of x and y are. So by substitution method, in the sense, write the first equation as y equals to 2x minus 2 and substitute this in the second equation, which is 5x plus 2 times of y is 4x minus 4 equals to 14. So 9x equals to 18, x equals to 2. If x equals to 2, y equals to 2. So last two questions. Solve the following pair of linear equations by substitution method. Again the same thing. This is 5 into y equals to 0. So 3x equals to 5y. X equals to 5 into y by 3. So 2 into x will be 2 into 5y by 3 minus 3y plus 15 equals to 0. This is 10y, taking LCM minus 9y plus 30 equals to 0. So y equals to minus 30. If y equals to minus 30, x equals to 5 by 3 of minus 30 is minus 50. And the last question is, there are two positive numbers such that sum of twice the first and thrice the second is 39. Let's say two positive numbers are x and y. The sum of twice the first is 2x plus thrice the second is 39, while the sum of thrice the first and twice the second is 36. So we need to find the larger of 2 here. So let me do it here. So multiply 3 for this and 2 for this. This is 6x plus 9y equals to 39 into 3. So it's 117, and this is 6x plus 4y equals to 36 into 2 is 72. Subtracting these two equations, 5y equals to 117 minus 72. 17 plus 8 is 35. So y equals to 7. If y equals to 7, x will be 3x equals to 36 minus 14, which is 12, x will be 4. The largest of these two is y equals to 7. 7 is the largest one. So that's all about the pair of linear equations in two variables. Let's meet in the next video in the next chapter.